Hello, this is our week 3, day 4 embedded video on reasonable domain and range of a real world problem. And once again, I'm going to be modeling the 3 reads to break down the information and using a table to get the numbers that we need to answer the question. So the first read is just to get a general idea of what the problem is about and then focus in on the goal. So first read, a pot of water at a temperature of 60 degrees Fahrenheit is placed on a hot burner. The water temperature increases at a rate of 25 degrees Fahrenheit per minute for 3 minutes. What is a reasonable domain and range for this situation? So generally speaking, this situation is about a pot of water being heated up on a burner on a stove for a certain amount of time. And then the goal, which I'm going to highlight, because I always highlight the goal, is what is the reasonable or a reasonable domain and range. So it's asking us for both. And I'm going to go down. That is the very first piece of important information that I'm going to write down is the goal. And I usually tell my students what in one word, tell me in one word, but this one actually has 2 things it's asking for, domain and range. So I actually need 3 words. But there's the goal, and that's the first read. Second read is to break it down into smaller chunks by putting a slash mark on the periods, and this is a shorter little situation, so there's not very many. Reading each little piece now and then writing down the important information. So first part of the second read, a pot of water at a temperature of 60 degrees Fahrenheit is placed on a hot burner. And yes, there is an important piece of information that it was 60 degrees Fahrenheit at the start. And remember, put your labels. So I'm going to put that this is the temperature at start. And other people might say, well, it's the temp when it's placed on the burner. So you can put that as well. And some people might ask, well, why is it 60 degrees? Because that was probably the temperature of the room. It's called room temperature. So if you just have water and you leave it out, or maybe that's the temperature coming out of the tap. Maybe it's a little bit cooler there, so it comes out at 60 degrees, but whatever the situation, that's the temperature at the start. And since we've done that part, I'm going to mark through it. Okay, second piece. The water temperature increases at a rate of 25 degrees per minute for 3 minutes. There's actually 2 important pieces of information there. The first one mentioned is the 25 degrees Fahrenheit. And again, you need to write down what that's for. And that's saying that the temperature is increasing. So I'm going to write down temperature and an arrow for increasing, and it's per minute, so then every minute. And then the next thing, it says that they were going to do this for 3 minutes. So there's a time limit here. We're not just heating up water forever. You've got 3 minutes that they're going to time this, and 3 minutes that they're going to look at taking the temperature. So this is like our time limit. And now I've done that piece. So that's the second read. The third read is to summarize to make sure that you've got everything you need to fully understand the problem and to get started creating the table of data. So just to summarize this, looking at just the breakdown side, make sure you've got everything you need. I know that this problem was about heating water on a stove. I need to find the domain and the range. I know that the water started out at 60 degrees Fahrenheit at the start when it was placed on the burner. I know that it is increasing by 25 degrees Fahrenheit for every minute that it's on there heating up, but I know that we're only going to do this for 3 minutes. So we're going to stop after 3 minutes, and we don't have to worry about how hot it is after that. We're just going to time it for 3 minutes. So that's a pretty good summary, and that's the 3 reads. From now on, when I look at the problem, I'm only going to be looking at the break it down area or my highlighted goal. Now I'm going to look at creating a table. And remember, when we create a table, we're looking at the X and the Y values. And some people call it the D and the R, so I guess I can write that up above it. D for domain, R for range, because remember, our domain is our X, our range is our Y. But then the other thing that we need to think about is, well, what is the X and the Y representing in this problem? So I'm going to go back to the break it down. You're looking for two different things that are related, that are being measured. That's another way to look at it, that are being counted or measured. So what are we measuring here? Well, one thing that sticks right out is minutes. We're measuring minutes because we're counting up to 3 minutes. So I'm just going to, and you can sort of highlight any place that you see that. I'm just going to do it here. I know I'm highlighting and counting minutes. And then the next thing that I see is what do the other numbers represent? The 60 and the 25, that's a temperature, and that is a measurement because that's in Fahrenheit. So I'm measuring temperature, or I'm counting how high does the temperature go. So the two things that you are measuring and counting, that's your X and your Y. You just got to figure out which one is which. So remember, X, the domain, that's the independent. Y, the range, is the dependent. Well, what is the dependent? Well, if I think about it, what depends on the other? Does temperature depend on the time, or does time depend on temperature? Well, the temperature is increasing the longer you leave it on there. So the temperature is depending on the time. Since the temperature is the dependent, since the temperature is the dependent, that makes it the Y range value, and the time, the minutes, is the independent domain X values. Another way to think about this is to think, well, does time depend on anything? No, time just ticks on by itself, so time is the independent, and you're counting the minutes, and as the minutes go by, the temperature is going up because you got it on a burner. So the temperature is the dependent. So now I've got that settled, I can start making my table. And whenever you're counting time, you really start, like, think of how a stopwatch works. You start at 0. So at 0 minutes, and then you can go up. Now you could go up by a half a minute, 10 seconds, whatever you wanted to. But over here it says that it's increasing every minute. So that means like every 1 minute. So I'm going to go up like 1 minute, 2 minutes. And I'm going to stop at 3 minutes because it also said that 3 minutes was my time limit. So there's my X side. Now I'm going to look at how I fill out the Y side. Well, what did it start at? Because remember, at time 0, that's your start. Well, it started at 60 degrees Fahrenheit. I'm going to put that in there. And then you have to add your increases. And it says up in here that it's increasing 25 degrees Fahrenheit every minute. So I know if I leave it on there for 1 minute, if I go from the 60 up to the next minute, I need to add 25 degrees. So 60 plus 25 gives me, now it's going to be 85 degrees. And then if I keep leaving it on there for another minute, I'm going to have to add another 25 degrees. And then if I leave it on there for the last minute, I'm going to have to add another 25 degrees. So I'm just adding on that 25 degrees every time it's on there for another minute. So now I have to add 85 plus 25, so then it's going to be 110 degrees. And then I got to add 110 to 25. So at the end, when you stop timing it, stop measuring it, it's 135 degrees. So that's the table of values that I'm going to use to figure out my answers over here. So I'm going to move this off because these are my answer choices. Okay, it says, what is the reasonable domain or range? So if I try to look at what's going on here, I've got domain choices and I've got range choices. Now that's one reason why you label. I've already got, I'm going to do it in green, that my X side is my D. So here's my domain. So if I look at here, I know that those values are involved. So it might be A, those got good values, but B has definitely got the wrong values. So I'm going to mark that off. But look at C. C also has some interesting values there. It's saying from 0 to 3, which is what my chart is showing. So it could be C as well, but it's definitely not D. So I can mark that off. And I can even do the same thing to the range. I know the range is the other side, so I know that A is definitely wrong. And I also know that C is definitely wrong because it just has the wrong numbers on there. Now to go back and figure out, well, then which one is it? Is it the one that looks like A and letter choice A on domain? Is it this one, A, and this one on range, A and B, because those are the discrete looking answers? Or is it in the continuous format, which would be the C answer and the D answer? So we have to figure out, is it discrete or is it continuous? Well, that is once again controlled by your independent X, which is your domain, and what that's talking about is minutes. And I tell my students, you have to decide if you can break that up into smaller and smaller pieces and it still makes sense and work and be reasonable. Like, instead of measuring a whole minute, could I, time it at a half a minute and look at my temperature on my whatever I'm measuring it with and get a reading? Well, yes, I could. Could I do it for less than a half a minute? So for less than 30 seconds. Could I do it for 20 seconds? Could I do it for 10 seconds? I mean, I would have to be like doing it really fast, but yes, technically you could do it every 10 seconds and get a reading every 15 seconds, every 30 seconds. So if you can keep breaking it up into smaller and smaller pieces, then it is continuous, because you really can't just write down just 0, 1, 2, and 3, because it's all the minutes in between as well. You can't just write down 60 degrees, 85 degrees, 110, because it's all those little temperatures in between there as well. So just writing a list like on A would be incorrect, okay, because you need all the minutes in between. So since this is continuous, the correct answer would be all the numbers in between and including 0 to 3, or all numbers greater than or equal to a 0 and less than or equal to a 3 as far as minutes go. And if the domain is continuous, so is the range, because the domain controls it. So I'm going to mark off the one that was discrete, and it's this one. It's all the temperature starting at 60 degrees and up to and including 135 degrees.